You know those incredibly complex systems, like the software that runs an entire airport? Ever wonder how they actually get built? You'd probably guess it all starts with thousands of lines of code. But the real secret, the real foundation, begins somewhere much simpler, by drawing maps. And to see how that works, we're going to head to the airport. All right, picture this. You're standing right in the middle of a huge, bustling airport. You've got announcements blaring, people rushing in every direction. 1,000 different things are all happening at once. It is a perfect storm of organized chaos. And then, right in the middle of it all, that little jolt of panic hits you. You pat your pockets, you frantically check your bag, and nothing. It's gone. Your boarding pass has just vanished. And believe me, this single, simple problem is just the very tip of the iceberg. In the world of software design, all these potential problems are called exceptions, things that break the normal flow. Maybe you're running super late and you desperately need a fast-track check-in, or you're just connecting flights so you have to stay in the transit area. Or, oh no, you fall asleep at the gate and miss your flight entirely. Or the real nightmare, you get all the way to passport control only to realize your passport is expired. Every single one of these is a potential system failure. So that leads us to the million-dollar question, right? How on earth do you design a piece of software that can gracefully handle not just the perfect, smooth journey of a passenger, but all of this potential chaos too? You definitely can't just start coding and hope for the best. The answer is, you don't try to build the real thing right away. Nope. First, you build a model. And I want you to think of it exactly like a map for your system. It's the guide that lets you navigate all that complexity without getting hopelessly lost. And here is the absolute key point. A model is, by its very definition, an imperfect picture of reality. Now, that might sound like a flaw, but it's not. It's a feature. The real power of a model comes from what it intentionally leaves out. This quote from our source material just hits the nail on the head. You are making a choice. You're emphasizing the details that are absolutely essential for the problem you're trying to solve, and you are purposefully omitting everything else. It's all about creating clarity out of noise. This table just lays it out so perfectly. On one side, you have reality, the territory, which is complex, overwhelming, and just plain noisy. On the other side, you have the map, our model, which is simple, focused, and crystal clear. It literally strips away all the background static to show only the essential details you need to make smart decisions. Okay, a map is great, but what if your system is so complex that one single map just isn't going to cut it? It can't show you everything you need to see. Well, the answer is simple. You don't use one map. You use a whole bunch of them. I mean, think about an actual map of Europe. If you tried to cram political borders, all the mountain ranges, and every single train route onto one single piece of paper, it would be a complete unreadable mess, right? So you have a political map, a geological map, and a transportation map. It's the exact same idea when you're designing software. So let's look at our first type of software map. This one's called a use case diagram, which is really just a fancy way of saying it's the who can do what map. It's super simple. All it does is show an actor, like our passenger, and what functions they're allowed to perform in the system. For instance, let's take issuing a boarding pass. Who can do that? Well, according to this map, both the passenger and a check-in representative can do it. See? This simple view clarifies who's responsible for what without getting bogged down in how they do it. It's all about roles and capabilities. Now for a totally different kind of map. This is a class diagram. If that last map was about who does what, this one is all about what things are. It describes the structure of the system itself. Think of it as the nouns, not the verbs. It's a map of the building blocks. For example, what even is a ticket in our system? This model tells us a ticket booklet is made up of multiple coupons. Simple enough? And what's a flight? Well, the very specific flight, PK 708 on January 26th, that's an instance of the more general idea of a flight number, PK 708. This map defines the fundamental stuff our system is built from. So we have different maps for different purposes. But professionals don't just doodle these maps randomly on a napkin. No, they use a standardized framework, a kind of master blueprint, to make sure that every single angle is covered. And that blueprint has this surprisingly simple, kind of memorable name. It's a framework used by pros all over the world, and it's known by this little formula, 4+1. It's called the 4+1 view model, and it's basically the industry standard playbook. It gives designers 5 different interconnected maps, or views, to guarantee that every single aspect of a complex system is actually thought through and documented. So here they are, the whole set. First, you've got the logical view. That's the what. It's the blueprint of the objects, like that class diagram we just saw. Then there's the process view, which is all about the how. This map shows how things interact, like how scanning your boarding pass at the gate triggers a check-in as the baggage system. The physical view is the where. Is this software running on some giant server in the basement, or is it on the check-in kiosk right in front of you? The development view, well, that's for the engineers. It's about who builds it, organizing all the code so teams can work at the same time without tripping over each other. And that critical plus one, that's the use case view we started with. It's the one that ties everything together and makes sure all this tech actually solves a real person's problem. So after all of this, let's circle back to the most fundamental question. Why go to all this trouble? Why spend so much time drawing all these maps before you write a single line of code? Well, it really boils down to three huge reasons. First, clear communication. These maps create a common language that everyone can understand. Second, visualization. They make abstract, complicated ideas concrete so everyone can literally see them. And third, verification. By laying it all out, you can spot gaps, contradictions, and mistakes before they become massive, expensive problems later on. And really, if you only remember one thing from all this, it should be this. Models aren't just technical documents for developers. They are, first and foremost, a tool for collaboration. They let everyone, analysts, programmers, managers, even the customers, look at the same set of maps and agree, yes, this is what we are building. It creates one single, shared vision out of all that chaos. So the next time you're facing a really complex challenge, whether it's at work or just in your own life, maybe pause for a second before you dive in and ask yourself, what would a map of this problem look like? What complex part of your world needs a better map?